Okay, so hopefully you've watched those videos. If you have not, please go back and rewatch the previous video and watch the ones that I referenced in that, because without that, you're going to be kind of lost at what we're doing here. So we're going to be programming in C# and programming / scripting. Yeah, same thing in this case. Cool. So what I want you to do is we're going to save this. If you hopefully you've already saved your scene, but I need to save that here. So I'm going to name this one Island. Okay, so I've saved this scene, and I'm going to jump back to the first one here because that's kind of the easiest one to deal with right now. So I've double clicked on it, and you'll notice, hey, where's all my stuff? Wow, that's really far away, right? Actually, I can double click on something, and it'll bring us in closer to that. So yeah, we don't have to like sit there and run through it all. All right, so here we go. Here is our scene that we started off earlier. Remember, I didn't save the particles on it, so that's cool. I didn't want to do that. So let's start looking at scripts. So let's go ahead and create our first script. All right, so I'm going to click on our box here, right? Our cube. Actually, I'm going to drag it off so it doesn't sit there and bounce. So I'm going to drag that off. So I've got our cube here selected. It's not really a cube anymore, it's a box. And what I want to do is I'm going to click here where it says Add Component. All right, so hit Add Component, and I'm going to scroll all the way to the bottom where it says New Script. Yes, there's something here that says Scripts. This is for scripts that are already in it. But we're going to go down here to the bottom where it says New Script. I'm going to click that, and so it's going to ask us some stuff here. All right, so first thing I should point out, you'll notice how the name is laid out here. It says capital N new, capital B behavior, capital S script. This is what is called camel casing. So in some ways, or in some rules, we're not allowed to put spaces in things, and underscores would be rude and anything like that. So we use this this way of writing, this camel casing, to allow us to quickly look at something that's all jammed together and figure out what is the first letter of each word. So we can do some, it can save us some embarrassing things. So so if I have a word, so if I have to put two things together, we can see what this really is, right? I'll leave that to your imagination as what the other version it was. So we'll get the giggles out of the immature ones like me. So yeah, this allows us to create some really fantastically long things that are perfectly reasonable to read. Like this is a long name that what is in it. So if I were to just put this all as lowercase, it would be really, really difficult to understand what I'm saying there, right? So you have to sit there and like, oh, what is this? Okay, this is, so with camel casing, we can kind of solve that issue. So camel casing is very useful. So let me close that out. All right. So we're going to hit Add Component. Also, one of the other things you're going to see is behavior is spelled wrong for Americans. That is because this is not an American program. Yes, they have offices here in America, but they were actually British. So they like to spell with lots of extra U's. So you'll see that. Also, one other kind of nibble of advice, or not advice, of trivia is that Unity was not originally a Windows game engine. It was actually a Mac game engine. So some of this user interface might make a little bit more sense after seeing that. So, all right. So we're going to name this one My First Script. It's not my first script, but you get the idea. All right, so you're going to see language here. This drop-down really doesn't mean anything because C# is the only language they support now. Earlier, there used to be JavaScript, which was kind of a mangled version of JavaScript. And then even before that, there was a Boo language, which, yeah, no one used that. So we're sticking with C#. And hit Create and Add. So I'm going to click that button. And what it does is it creates a file and adds it to our object here. Give it a second, it's going to figure out. See, and one of the nice things is because I camel cased it, it knows how to split this up. So My First Script, easy to read, right? Okay. Right now the script is not doing anything, so let's go ahead and edit it. So I'm going to double click on it, and it's going to fire up Visual Studio here. Okay, so if this is your first time opening Visual Studio, which it shouldn't because you should have watched those videos, it's going to ask you some questions. Just stay with everything that is C# related. All right, so this is a default script for Unity. So it's got a few things here. So it's got some usings up here, and these are basically saying, bring this stuff in because I might use it in the future. All right. You'll also notice that we've got some curly braces here. Each one of these, for example, the class here has its own. I personally do not like it like this. I like to have my curly braces looking like this, but it's one of those, personal preference things. So this is personally the way I like it. If you've ever seen that rabbit season, duck season thing on Bugs Bunny, it's like that. Either way doesn't matter. And you could even be a real jerk and do this, and it would still technically work. Well, yeah, it would just absolutely work, but you're a jerk for that because it makes it harder for people to read. So I'm going to undo that change. Okay, so let's look at this here. So this is a class, all right? Inside of it, it is taking in a mono behavior, which this mono behavior is basically some of the functionality of Unity that we get. There's some other stuff that are coming in later. So this gives us extra functionality for start and update and all that good stuff. All right, so let's go in here let's describe these two. So I like to call them functions, but there's a better technical name. I just don't deal with it. I like to call them functions. So the start function here is used for things that happen just after the thing has been created. So whatever your script is attached to, when it's created, it runs this code that you would write in here. So if you want it to, print something when it starts up or set some values, you can do that. Now, underneath that, we have update. So update runs once per frame. So if your game is running at 60 frames a second, this will get run 60 times in a second. It's running 120 frames a second. This will get run 120 times in a second. It's running at 3 frames a second. It'll run 3 times in a second, and so on and so forth. So just keep this in mind when you're doing these here. So the first thing I want to do is let's go ahead and let's do something here. Let's have it print something out. Now, a lot of people, when they're teaching you programming, they like to go through and do some math first and things like that. But personally, I don't like that. I like to show you, I like to have it show you something immediately and be interactive. So we're going to start off with that. So what I want it to do is print out something in the console. All right. So to do that, we have to access some of the debugging stuff. And that's actually pretty easy. So what we're going to do is we're going to use capital D debug. All right, capital D debug. This is an object here that helps you with debugging. All right, so we're going to hit period after that, and inside of that, we are going to look for something called log, and that's going to be capital L log. All right, and remember, capitalization matters in this case. And then we're going to do an open parenthesis, and we're going to put something inside of this. In Visual Studio, when you type an open parenthesis, it'll type a closed parenthesis as well for you. So what I'm going to do is I'm going to do a quote, and again, it does the same thing here, and I'm going to put a message. We're going to have it print out hello world. All right, you'll also notice at the very end there's this angry red squiggly there. That means we're missing something. In fact, Visual Studio, it says, hey, you're missing a semicolon. So it's like that English teacher that got angry with you when you forgot something like that. So we're going to hit a semicolon there. All right, so we've done that. We need to save. So we could go up here and click this save button here, or this one right here, which saves everything, or we can hit Control S as well. All right, so we've saved that. Let's go ahead and go back to Unity here real quick. All right, so I'm going to hit play on this, and actually before I do that, before I hit play, I'm going to go over here to the console. All right, I'm going to hit play now. Doink. See, hello world. It had that print for us. All right, so you're thinking, okay, that's cool, but what is this good for? Well, this allows us to give you, as a game designer, or even as a programmer, a message. So, for an example, I was working on a Guess the Number game a while back. So the idea is that you're trying to guess a number, and it's going to give you back how many of the digits are correct in the order that is correct. You know, the order that, or the number that are in the correct order. So what I did on each round, I would have it print out what the actual number is. So if I were testing, I could easily, test a win or lose condition without having to work for it. So that's things that you can do with that. All right, so that's on that's the start one there. So we've done that. Down here, let's go ahead and do something in here. We're going to do the same thing. We're going to do debug. Oops. And what's really cool is if you highlight it and hit tab, it'll complete it for you. All right, debug.log, capital L log. All right, and we're going to type, I'm going to do like frame. Space. Put a semicolon at the end, so it's happy. Can you see what's going to happen here? All right, so let's go ahead and run this. See, it's printing frame for every frame that occurs. If you're not seeing this drag out like this, turn off collapse, because collapse will do this. Make sure that's kind of popped out there. Cool. So we're just printing it over and over for every frame. So we've got more than 1,000 of these. Cool. Okay, so I've got the button clear on play there, so it'll get rid of all this stuff when we're done, or we can just hit clear. It's okay. So we have a printing frame for every frame, right? So what I want to do is I'm going to go here, and I'm going to make it count up. All right. So we need a variable that's going to hold a value for what frame number it is. And that's pretty easy. So I'm going to do public. Oops, if I can spell, not int, and I'm going to name it frame count. All right. So I'm going to set frame count to nothing, actually, because I'm going to show you something about that. All right, and we're going to take this frame count and we're going to string concatenate it to the to what we were already printing. That basically means put two strings together, even though it's an int. All right, so I'm going to save this here, Control S, and we're going to play this real quick. And see, it's saying frame 0, so it's printing that, but we need to do stuff with it. And you'll notice here it says frame count, it says 0, and we can actually modify that number. So if I hit play on here now, see, and you can even modify while it's running. Because that is public, that's the reason why it'll show up there. All right, so let's go back to the code and let's modify this code. All right, so we want frame count to count up every frame, right? We want it to do it by itself, right? Otherwise it'd be kind of useless. So we have multiple ways of doing this, and if you've watched the videos, you'll know each one of these, but this kind of quick reminder here. So the long way we could do this is we can take frame count and assign it itself +1. And that works fine. So I'm going to save this. We'll run it real quick. Oops, we started on 250 something. But yeah, it's counting up now. So let's actually send that back to 0. All right, and we'll run it again. See, it's counting up. But one thing I want to point out to you, so I'm going to scroll up to the top here. So we have our hello world. But we also have frame 0 as well. So I just wanted to point that out. So that's really the long way of doing this. So what I'm going to do now is I'm going to comment this out. Basically, that means it tells the computer to ignore that line of code. All right, so we've got a quicker way we can do this. We can do frame count plus equals 1, semicolon. All right, so we've done that, and we can show you that works. There you go. So that's a lot quicker to type, right? But there's an even shorter way of doing this. But this only works with 1 at a time. So what I'm going to do is I'm going to take frame count, and I go to the end of frame count. I'm going to do ++. So what this does is it increments our thing there, right? Our count. So I'm going to save this, Control S, hit play on that, and there we go. But we still run into that pesky problem of having 0 as our first one, right? So let me show you what's happening here. So when it gets to run this line of code, the first thing it does is it looks at everything here and goes, okay, we're going to print out frame plus the value of frame count. And then when it's done, it comes back and adds 1 to frame count. And so next time it's, frame count equals 1. Well, one of the things that we could do is we can actually move this ++ to the beginning of it. So I could erase that and just put it up there, but I can also do this. I can highlight it and drag it to the beginning. And that's really any text. So I could literally do that here. And that would work as well. So what is going to happen now, though, is first thing it's going to do is going to look at this line of code and go, oh, hey, I need to add 1 to frame count first of all. All right, so it's going to do that, and then it's going to run this line of code. So then it'll, even on the first frame, it's going to go frame equals 1 because it's already added 1 to it. So let me go ahead and save this here, and we're going to see this run. There we go. The first frame is frame 1. Isn't that cool? Okay, so we've got printing stuff out, and we can see things going on. So yeah, we could add, subtract, multiply, divide. You've already learned all that stuff. So what I'm going to do is I'm going to comment this out. And wouldn't it be nice if the code that we wrote modifies what we're seeing on screen, right? Maybe we can make that that block spin, right? Let's do that. So what we're going to do is we need to access the object that we're connected to, that our script is attached to. And the way we do that is using game object, and that's lowercase g game object. There is an uppercase G game object, and what that is basically what everything of Unity is made of. So it's a type. It's like a generic type that has to do with Unity. But what we want is the lowercase g game object. That's the component this thing is attached to. So we're going to use lowercase g game object, and then hit period, and we're going to go look for transform. All right, so that's lowercase t transform. Hit tab on that. All right, so I'm going to take that. I'm going to hit period on here, and we are going to go find rotate. And that's capital R rotate. That's the one we're looking for there. So hit tab on that. All right, and then open parentheses. So one of the things I want to point out here, underneath that, we have some kind of, a little cheat there that we can see what's going on. So there are 6 different ways I can use rotate. The first one is using a vector 3 of Euler angles. Yeah, I know it looks like Euler, but after a while you find out that it's actually someone's last name and it's pronounced Euler. All right, so we're going to scroll down through these. I'm using my arrow keys. So the second one is a vector 3 of axes, and we're going to set the angles now. Well, we can do a vector 3 of Euler angles and then do relative to, yeah, we're not going to deal with that one. We can set the angle using floating point values. That's not what we want. We can use a vector of axes, a float of angle, and do relative. Nah. But what we really want is the last one here. So we have the 3 angles and relative to. And we're going to talk about what this is like. All right, so there are 2 ways to rotate an object. All right, according to its own axis. So an object that you model is going to have its own axis, its own X, Y, and Z. And so is the world. It's going to have its own X, Y, and Z. All right, if the object at all rotates in the world, its X, Y, and Z are going to be different than the world's X, Y, Z. All right, so if you're let's say modeling a space fighter, right? So the world's Y is going to always point in the same direction, but as you fly through space and your ship turns, the Y axis of your ship is going to change as it goes through as well. So this setting here allows us to do that, allows us to set how it works. All right, so the first thing we're going to do is we're going to put in some angles. So we're going to rotate along the X axis right now. So let's go ahead and have it rotate 90 degrees. So 90, and we're going to put 0.0f. So that tells C# that we're dealing in floating point value. That 0.0f says, hey, this is a float. Sometimes you can get away without the 0.0, but you still need the f. All right, so that's the x-axis. The y-axis we're not going to do anything on, so 0.0f. And the z-axis is the same thing, 0.0f. All right, finally, we're going to work on space. So we need to tell it whether it's relative to itself or the world. All right, so we're going to do capital S space, hit tab, and hit period. And it's going to give us a choice, self versus world. So I'm going to do self. All right, I'm going to put a semicolon at the end, and it actually kind of pushes itself out so it's easier to read. All right, I'm going to save this, and we're going to go ahead and run. I want you to see what happens here. So you may already know. Hey, look at that. It's kind of hard to see, but our thing is rotating at 90 degrees a second, or 90 degrees a frame. Because remember, I said that code runs at 90 frame, or that runs at however many frames per second you're running. So yeah, whoops. Let's fix that. So we want to do 90 degrees in a second. All right, so that's not terribly bad. So what we needed to know is how much time has passed since the last frame. All right, so if we are running at 1 frame a second, then this would be okay because we'd be rotating 90 degrees in 1 second. If we're running more than 90 degrees at a second, so if we're running at, or I'm sorry, if we're running more than a frame a second, say we're running at 2 frames a second, well, what we would do is we would need to find a way of kind of cutting down this number. So we would want to, if we're running at 2 frames a second, we want to turn by 45 degrees, right? Instead of 90. Or if we're running at 10 frames a second, we want to turn 9 degrees in a second, or 9 degrees in a frame, right? So on and so forth. We have a way of doing this. We already have a variable that stores this information. So what we're going to do is we're going to multiply this number by something that sounds really cool. It's called capital T time dot delta time. So this represents the amount of time in seconds it took to complete the last frame. Very handy. So watch this. I'm going to save this. We'll go back here and run it. It runs at a nice, smooth rotation. And what's really cool is it doesn't matter your frame rate because it's taking into account that. Now, you can't always guarantee what the frame rate of the user is going to be. It might be faster, it might be slower, so we can't hard code these numbers. Basically, we have to have Unity tell us what it is. And we do. And by the way, yes, we can have our rotating block affect other things as well. So yeah, we could jump on this if we wanted to. Maybe I got too high. But if I go over here and crouch down, see, it's affecting me. Let's try that. See. Oops. Okay, so it's too high and too low, but yeah, it does affect us there. Cool. So a nice rotaty one there. So that's one of the things that we can do. All right, let's continue on here. All right. So if you want to take a break for a second, this is a good place to pause. But we're going to move on. Anyways, we are going to cause this to interact. We're going to have it do something if we run into it. Cool? So let's do that. All right. So let's do this. What I want you to do so I want you to go into here. So you're going to put your cursor between these last 2 curly braces. These last 2 curly braces represent the end of the class. All right. Well, we could go up here and do it as well. It's up to you. So I'm going to go down right here, and we are going to type the word public, and then the word void, and we're going to type OCE, all caps, OCE. So if all your stuff is working absolutely perfectly right, you'll see on collision enter appear. All right, so I'm going to hit tab, and when I did that, it filled this whole thing out for us. Technically, if you're really brave, you could just type OCE and let it finish that out, all caps. You can do that as well. So what is this? This is another function. So this one's very specific. So when something initially collides with our object, it's going to run this, and it's going to give us information about what happened here in collision. So right now I'm going to have it print something out. So I'm going to debug .log. Kaboom. All right, I'm going to save that. All right. So if you need to come back and look, if you have to type it in because it's being ornery and not taking it, go ahead and do that. Pause the video and then, copy and paste there, right? Or type it in. All right, so I've done that. Let me go ahead and save, Control S, and let's go ahead and run this. Okay, so it's not doing anything down here. Well, yeah, not doing anything right there. So I'm going to walk up to it, and when I run into it, it's going to go kaboom. See? Every time it runs into me, it goes kaboom. Cool. And of course, we can run into the end there. The reason why it's repeating is because every time one of the corners hits, that's a new collision because it's kind of let go for a second. Cool. So let's go in and modify this. So we've got it printing every time it collides, but we could have it do more, right? So I'm going to get rid of this. All right, so what I'm going to do is I'm going to type in some voodoo, basically. And let me type it in, and I'm going to come back and explain. All right, so let me go ahead and explain this here. So this is a little bit of voodoo, but that's okay. So what we're going to do is we're going to change the color. So we need to access the part of our object that can change the color itself, and that is called the renderer. All right, so what I'm doing is I'm getting a type called renderer. I'm creating a variable here to store our renderer. And then we're asking the object that we're attached to look for a component inside itself called renderer, or of type renderer. It gives me back that, and we store it here. Inside of that, that renderer, we have a variable that will hold our material. And what we're going to do is on that material, we're going to set its color with a marker for the color itself, as opposed to other things. And we're going to set it to the color magenta. All right. So we're going to save that, and let's give that a try. Doink. There we go. But it's staying the same color, and it's not getting any more purple or magenta-y, right? Basically, once we set it, that's how it works. All right, so we get it to change to that color, right? But how do we get it to go back, right? So we won't run into it and change the color, right? Well, we have on collision enter, right? Well, if we have that, don't you think we might have an on collision exit? Well, we do. All right, so I've filled that in here. I'm going to copy this down here real quick. Control C, Control V as in Victor. All right, we're going to change the color from color.magenta to color.white. The reason for the color changes here, this is kind of like a turn only these colors on, turn only that color on. So white, remember, is red, green, and blue all on, maximum intensity. So yeah, we can save that. We're going to jump back here and run this. Now, watch this. I'm gonna run into it. Doink. So every time when the corner hits our collision, there it is. Looks like a heartbeat, but you know, one you should probably have checked out, right? Cool. All right. So that's pretty cool. We've done things like that. One of the other things I want to show you, though, is you see how we're doing this twice here? All right. Well, let's say we're going to do something kind of often. Well, one of the smart things to do is to actually write a function that does that. Now, if it's just literally two things like this, it might not make too much sense. But if you're going to do this often, this is what you should do. All right. So we're going to write a function here that's going to do something for us. All right. So let's try this. We're going to do private void, because I'm not going to return anything, and I'm going to change the color. All right, so we're going to take in a color. Okay, so we've got that. So change the color. All right. We're going to do curly braces below this, right? Okay, so we've got that. It says what color, right? So I'm going to take this. I'm going to highlight this. Actually, what I'm going to do is I'm going to drag it up here. Doink. I'm going to fix the tabbing here just because it looks pretty. All right, so I'm going to replace this color dot magenta here. I'm going to get rid of that. All right, and I'm going to fill it in with what color? All right, so when this is run, it's going to run this with the value that's being passed in, filled in there. All right, so what that means is I can do this. Change the color, open parentheses, color dot, oops, dot, not comma, dot magenta. All right, and I can do that same thing here. Replace this. Dot white. All right. You're thinking, well, okay, why would I do that? Besides, if I'm doing it a lot, it could save me some typing. But also what it can do is if we find a bug up here, we only have to fix it one place, which is kind of nice, right? Say, oh, hey, I made a mistake. Now I don't have to go copy and paste it all over the place. I can just go, oh, fix it right there, and it's done. All right, cool. So let's go ahead and save that, and you can see it running. All right, let's go ahead and walk up there. Doink. See? Works out. Life is good, right? Let's bump this over there. Oh. Oh well. Cool. Okay, so that's collision detection actually. That's some pretty good stuff there. And Unity handles it for us. So we have on collision enter, we have on collision exit. There is actually another one called on collision stay. So that runs, I believe, every frame that the collision is occurring, but we don't need that too often. So it is there if you need it. Okay, so I'm going to pause this recording. We're going to continue on in a little bit with some more.